Hello, my name is José Antonio Mulet. I'm a PhD student at the University of Brescia and fellow researcher at the STIMA Institute in Milan, Italy. Today I would like to present our work consisting on the assessment of performance-based interactions in collaborative cyber-physical production systems. This work has been carried out in the context of the Demanded project under a Marie Curie action. I will firstly define our main motivation to develop this work. Then I will go ahead with the proposed model and the description of the main dimensions which form the model, and then finalizing with main conclusions and future work. Customer requests of highly customizable products are challenging current manufacturing systems and the manufacturing paradigm that industry knows nowadays. This new market trend requires highly flexible manufacturing systems that allows the production line to be rapidly changed, then meeting requirements of concepts like the mass customization, or the most challenging one, taken from the lot size 1 concept. Cyber-physical production systems are revealed as the technological disruptions capable of reaching these highly unpredictable and complex requests, maintaining sustainable aspects proposed by the European strategies. These strategies not only attain environmental aspects but also social ones. And in this concern, the responsible adoption of the operator's roles stands for the creation of new values with reference to individual activities rather than tasks, and the adoption of human-centered approaches instead of the current techno-centered one, which focus on automatizing most of the tasks. Even though a lot of research has been done concerning the human role and concepts like the Operator 4.0, there exists a practical necessity to establish a repeatable assessment method that would set appropriate performance metrics, directly linked with the industrial production, that can capture critical operator states influenced by the collaborative nature of the interactions between humans and machines. Said that the main objective of this work is the definition of the model that helps establishing performance-based indices in collaborative systems. Even the approach might be applied to any collaborative CPPS scenario, we focus on collaborative environments implemented by collaborative robots for the physical interactions. The model we propose is divided in different dimensions: the user, the machine, the collaboration, and the performance indices important for the production. Following slides will explain in detail all these dimensions and why they are important when setting performance indicators and a practical point of view, which might be understood as how feasible is to measure them. Firstly, according to the user dimension, the context plays a major role since it establishes the engagement of operator with the specific task. Then we can define the operator fatigue as one of the main factors that influences productivity and safety and is directly related to the balance of workload while preserving the situational awareness. Workload can be classified in physical and cognitive or computational when considering artificial systems. Physical workload can be easily measured by monitoring physical operations, but cognitive monitoring is not easily addressed. Situational awareness is defined as the ability to perceive what is happening around to predict what will happen in the future, and is driven by the supply of attention resources, their demand, and the operator's understanding of the task. It results in internal challenges of mental models and has a strong effect in the decision-making process and consequently in the production performance. According to this dimension, different approaches can be used to measure these indices, like the multiple resource model architecture, the situational awareness rating technique, or the widely known MSC-LES. According to the machine dimension, we might classify main indices in global or local, kinematic or dynamic, and intrinsic or extrinsic to the task that is performed. Challenges arise from the proximity to low performance configurations or singularities and the effective use of the workspace. Some of the main indices are joint performance indicators, manipulability indicators or redundancy, and isotropy and task related, like the ellipsoid isotropy or the layout condition index against and others. Trust is the main pillar in collaborative interactions and is defined as a cognitive attitude that holds the belief that the collaborator will perform as expected to accomplish the main objectives. An improper calibration of trust produces system disuse, misuse, and may cause accidents. However, the importance of trust is also due to the sources of its creation, which might be human-related, like the abilities and personal characteristics, robot-related, such as the performance of our attribute factors, and from the environment, like the collaboration and task-related. Some approaches to measure trust suffer from intrusiveness by using questionnaires and then affecting the results, or the automatic psychometric instrument, or the use of automatic psychometric instruments. This last approach is quite promising, but the dynamic behavior and long-term changing nature of familiarity process challenges this method. Safety is of high importance in collaborative systems, especially on those with close physical interactions, as we can see in the number of standards that define this interaction. From the practical point of view, the importance of risk and hazard identification methods, especially those which assume human actions, are of special interest to identify potential unsafe situations. Then, advanced verification and validation methods assure continuous monitoring of unsafe situations as consequence of malfunctions of the software or hardware. Even though the initial steps are important to deploy safe systems in industrial scenarios, continuous monitoring mechanisms must be considered during the operational phase as well, due to the evolvability and complex nature of the future manufacturing systems as consequence of their digitalization. Most of the production indices have been widely studied for decades now, but are mainly built around collaborative objectives. Some indicators can be established according to production rates and capacities, quality of products, or in individual production lines behaviors, like downtime for maintenances, or changes in tools and components. Describe all previous dimensions, I would like to introduce our use case, which is created from an industrial manufacturing scenario for the production of small batches and electronic printed circuit boards. Main challenges of the automated solution can arise from the manipulation of operations of flat and small objects, the wide range of product designs, and the positioning requirements. However, the challenges to deploy a fully collaborative solution comes from the production requirements according to quantity and quality, the correct balance of the workload between the machine and the human, and the necessity to meet safety standards. In this slide, you can also see a division of operations and the tools needed according to the different phases of the whole industrial process. This slide presents a list of tentative indices extracted from the model we propose, which are relevant to measure the performance of the proposed system and their description. In conclusion, it is of huge importance the analysis of the implications the deployment of highly digitalized systems has in industry, and the importance of a correct assessment of interactions to keep high values of performance. Trust and reliability are set as the main pillars to keep performance values high. We would also like to highlight the importance of the context during the whole analysis, and also the variance with reference to time along the whole life cycle of the manufacturing system, not only focusing on the design phase, but also during the operational phase. Future steps will cover the analysis of the use case and how previously exposed indices will be adapted to a completely automated solution and a manual one. That's all from my side. Thank you very much for your attention, and I will be available for answering your questions in presence during the conference and also in this email. Thank you very much again.